Welcome to today's deep dive. I am incredibly glad you're joining us today because our core mission for this session is to explore how the way we learn, like really complex high-stakes skills,
Mm.
is about to fundamentally
Yeah,
change.
it's a massive shift.
Right. And we are looking at a really fascinating stack of source materials today, specifically an April 2026 announcement and the accompanying technical materials from EON AI Ventures.
Right, about their new platform update.
Exactly. They've just launched something called Conversational Scene Authoring for their EON Genesis 3.0 platform. And our goal over the next several minutes is to understand how this technology is attempting to bridge a very dangerous, very expensive gap between, boring training manuals and actual hands-on
It's a
experience.
gap that's been causing headaches for decades, honestly.
Oh, absolutely. So, okay, let's unpack this.
Yeah.
Imagine for a second that you have just been hired for a job where the stakes are incredibly high.
Right, like life or death stakes.
Exactly. Maybe you're operating a multi-million-dollar piece of heavy machinery on a manufacturing floor, or maybe you're learning how to calibrate complex, life-saving medical equipment in a hospital.
Yeah, highly technical environments.
Right. So you walk in on your first day training, ready to get your hands dirty, ready to learn the ropes. And what do they give you? A 300-page, completely dry, text-heavy binder.
Just a standard operating procedure document. It's almost comical.
It really is. You're expected to sit there under these buzzing fluorescent lights, read the text, look at a few like static two-dimensional diagrams, and somehow translate that into physical high-stakes muscle memory.
It is a terrifying prospect, really. And I mean, it asks something of the human brain that we are simply not optimized to do.
No, not at all.
The cognitive leap required to go from reading, black text on a flat white page to actually manipulating complex valves, levers, or like surgical tools in three-dimensional space. It's immense.
Yeah, it's like trying to learn how to ride a bike by reading a physics textbook.
Exactly. You're asking a trainee to build this perfect mental simulation of physics, spatial relations, and consequence entirely from scratch in their head. And frankly, if we look at the historical data across industrial sectors, that translation gap is where a significant portion of critical, sometimes fatal errors originate.
Right, because reading about how much torque to apply to a valve is completely different from actually feeling that resistance in your hands.
Exactly.
Now, if we contrast that binder with, say, putting on a headset or opening a screen and actually stepping into a simulation, you are physically doing the task. You're pulling the digital levers. You're making the inevitable beginner mistakes in an environment where they don't cost lives or millions of dollars.
Which is where everyone intuitively wants to be. We all know that hands-on simulation is just better.
Right. And the source material actually backs this up with some truly staggering metrics, right?
Oh, yeah. The effectiveness of extended reality or XR training is, well, it's no longer up for debate in the scientific or corporate communities.
The numbers are pretty definitive.
Very. When employees learn in these immersive 3D environments, the data shows they learn 4 times faster than in traditional classroom settings.
4 times. That's incredible.
Yeah, and it gets better. They walk away with a 275% higher confidence in actually applying those skills on the floor.
Wow.
And perhaps most importantly for like long-term operational safety, they retain that knowledge 75% longer.
Those numbers are wild. So 4 times faster, massive retention, way higher confidence. But that brings us to what the sources highlight as this massive contradiction in the corporate world.
Right, the paradox.
Exactly. We have this methodology that works. The data completely proves it works. And yet, this glaring, almost absurd reality remains. 98% of industrial companies still do not use immersive training.
Yeah, it's the definition of what industry analysts call the XR paradox.
The XR paradox.
Right. You have an educational methodology that is objectively superior in almost every measurable way, and yet market adoption is sitting at a mere 2%.
It's crazy. I was trying to think of a way to frame this paradox. And, it's like discovering a supervitamin that makes you run 4 times faster.
No, I like that.
Right. It's a miracle pill.
Well,
But the problem is it costs an absolute fortune, and it takes a whole year just to manufacture one single dose.
that analogy actually maps perfectly to the software development bottleneck we're seeing.
Because the bottleneck is the real issue here.
Exactly. The source material gives us a very clear diagnosis of why that 98% is locked out, and it really just comes down to prohibitive complexity and astronomical cost.
Like, how bad are we talking?
Well, historically, if a company wanted to build one of these immersive training modules, they couldn't just use, standard corporate software like Word or Excel.
Right.
They had to rely on existing video game engine platforms, primarily Unity or Unreal Engine.
Which, to be fair, are incredible platforms. I
Yeah.
mean, we get amazing video games from them.
Oh, they are phenomenal pieces of software. But there are professional development environments. They demand advanced programming skills, usually in C++A, and expert-level 3D modeling, rigging, lighting skills. It's a lot.
So, like, a standard corporate trainer isn't just going to fire up Unreal Engine on their lunch break.
No, absolutely not. If an oil company wants to train its workers on a new rig, the subject matter expert at that oil company cannot build the training. They have to hire a proxy.
Right.
They essentially have to hire an entire video game studio to build their safety training.
Which explains the time and the money. The sources state that developing a single, solitary XR training module using these traditional methods can take anywhere from 6 to 12 months.
A year for one module.
Yeah, and the financial cost is sitting between $50,000 and $200,000 per module.
And we really need to emphasize that is per module.
Right, it's not a one-and-done platform fee.
No. If you're running a manufacturing facility with, say, 50 different machines, and each machine has 3 different maintenance procedures,
Oh man, the math on that gets scary fast.
you are suddenly looking at millions of dollars and years of development just to get a baseline training program off the ground.
Yeah.
So for companies without massive, dedicated software development teams, these barriers entirely lock them out of the advantages of XR.
And the real-world consequences of that lockout are severe. I mean, it means slower time to competency for new hires.
Right.
It means critical knowledge attrition when veteran employees retire and, just walk out the door with decades of expertise in their heads.
Exactly. It's lost forever.
Right. And ultimately, it means increased operational risks. So the problem isn't the training itself. The problem is the massive bottleneck required to actually create the training.
Which is exactly the bottleneck EON AI Ventures is claiming to shatter with Genesis 3.0.
So this is where the pivot happens.
Right. We are looking at paradigm shift from needing a whole team of software engineers to essentially just talking a training module into existence.
Okay, let's get into the main event here. The sources detail this new feature called Conversational Scene Authoring.
Yes.
And the promise is that a subject matter expert can take one of those dry, text-heavy standard operating procedures, an SOP, and turn it into a fully interactive 3D training environment in minutes.
Minutes, yeah. Down from 6 to 12 months.
That's a staggering claim. And they can do it with zero coding, zero 3D modeling expertise, and zero technical teams.
It fundamentally compresses the entire development lifecycle, which in turn drops the cost to near zero. You are completely removing the video game studio from the equation.
Okay, here is where I have to push back a little bit.
Yeah.
Because I think a lot of people listening are going to have the exact same skeptical reaction that I did when I read this.
That's fair.
We have heard these no-code promises before. Over the last few years, the tech world has been flooded with generic drag-and-drop platforms that promise to make you a developer in 10 minutes.
Right, the whole democratized coding trend.
Exactly. But they almost always end up being incredibly clunky, very rigid, and frankly, far too simplistic. If I am training an aerospace engineer on how to calibrate a jet engine, I cannot use a generic, cartoonish drag-and-drop tool. How is Genesis 3.0 avoiding that trap?
The skepticism is absolutely warranted, and it's a distinction the source material explicitly addresses. Generic drag-and-drop tools have consistently failed in the enterprise space, precisely because they lack the nuance required for high-stakes industries.
Well, they just don't have the fidelity.
EON AI Ventures draws a very hard line in the sand regarding precision. Generic AI tools might deliver an output that is, say, 80% accurate to the real world.
Yeah.
But when you are dealing with deep-sea oil rigs, aerospace engineering, or clinical healthcare, 80% is a failure state.
Right. You can't be 80% right about which high-pressure valve to shut off in an emergency. The rig explodes.
Exactly. It has to be perfect.
Yeah.
Genesis 3.0 is built specifically for environments where precision matters. It is an enterprise infrastructure, not a consumer application.
Okay, so it's specialized.
Very. But what really separates this from the clunky tools you mentioned is how the artificial intelligence parses information, which we can get into. But first, there is a deployment factor that drastically changes its usability.
Oh, right, the browser.
Yes. The entire authoring platform operates completely within a standard web browser.
I am stuck on this browser aspect, to be honest. The sources emphasize no local cloud GPUs, no complex plugins, no massive installations.
Maybe a download.
Right.
Yeah.
But if we are talking about rendering a complex, physics-accurate 3D simulation of an oil rig that usually takes a massive local graphics card.
Hmm.
How is a standard web browser handling that workload without just instantly crashing your laptop?
It represents a massive leap in how web architecture handles three-dimensional data. Instead of forcing the user's local computer to process and render every single polygon and physics calculation simultaneously,
Which would fry most laptops.
instantly. Instead, the platform utilizes highly optimized streaming of geometry. It is delivering the visual and physical data to the browser almost like a video stream, but one that is perfectly interactive.
Okay, huh.
It shifts all the heavy lifting away from the user's local hardware, making the technology instantly accessible to anyone, anywhere, on almost any device.
Okay, that accessibility is huge.
Yeah.
Completely removes the hardware barrier.
Good.
But I want to look under the hood now. I really want to know the literal mechanics of how a plain text document actually becomes a 3D world.
Yeah, it's a fascinating process.
Because it sounds like magic.
Yeah.
But obviously, it is a combination of natural language processing and spatial computing. So how does a wall of text actually generate a room?
The platform uses a very specific two-phase process to ensure both the speed of creation and that 100% accuracy we just established is mandatory.
Okay, 2 phases. What's phase 1?
Phase 1 is called automatic bulk import. You, as the trainer, upload your written SOP document. The AI parser immediately analyzes the text and automatically generates 60 to 70% of the 3D training interactions.
Wait, I need to understand the mechanism there. It's not just like scanning for nouns, right? How does it actually know what to do with the text?
It is entirely reliant on advanced natural language processing mapping to spatial logic.
Spatial logic.
Right. The AI isn't just looking for a noun to populate a room. It is actively analyzing the operational verbs in your manual words like turn, pull, calibrate, or release, and mapping those actions directly to specific physics engines within the software.
Oh, wow.
Yeah, it is literally translating a written English sentence into a spatial coordinate and a functional logic tree.
So let me get this straight. The AI, using what the source calls fuzzy mesh matching, is essentially playing a high-speed game of I Spy.
That's a really good way to put it.
It reads the manual, searches a massive digital library, grabs the exact 3D wrench needed, and instantly knows how that wrench is supposed to move.
Exactly. And it's finding that specific object through that process you just mentioned, fuzzy mesh matching.
Right. Okay, let's break that jargon down. What exactly is a mesh, and how is it fuzzy?
Okay, so in 3D modeling, a mesh is essentially the digital wireframe or skeleton of an object. It's the geometric structure.
Like the 3D outline.
Yes. And the term fuzzy in computer science means the system doesn't require an exact, perfectly typed string match to find what it's looking for. It doesn't need a specific 12-digit part number.
So it's not searching a database for like valve underscore type underscore 4B.
Right, exactly. If your standard operating procedure simply mentions a standard pressure release valve, the AI looks at the context of the entire document, searches its massive digital library of 3D meshes, and makes a highly educated fuzzy guess to grab the structurally correct valve.
That is wild.
It grabs the exact geometry, defines the movement rules based on those operational verbs we talked about, and it even configures the ambient effects.
Wait, ambient effects, like
Yeah.
lighting.
Lighting, sound, particles. If the text mentions a pressurized steam release, the AI automatically configures the appropriate sound effects and particle visuals for that steam. In seconds, the bulk of the tedious development work is completely finished.
That is incredible. But, as we discussed, phase 1 only gets us to, what, 70% completion?
Roughly, yes.
And a 30% chance of failure on an aerospace simulation is totally unacceptable. So how do we close that final critical gap without calling those software developers back in to fix the code?
Which brings us to phase 2, conversational refinement.
Conversational refinement.
Right. Because high-stakes training needs absolute 100% accuracy, the human expert must be in the loop to verify and adjust the simulation. But instead of the expert trying to explain what they want to a developer, who then spends 2 weeks tweaking the code.
Right, playing a game of telephone.
Exactly. The expert just speaks directly to the digital environment.
Just using natural language.
All right.
Like talking to a person.
Yes. The sources provide some very tangible examples of how this works. A trainer can literally just look at the simulation running in their browser, use a click-to-select functionality to highlight an object, and say out loud, "Spin the fan faster," or "add a warning sound at high pressure."
It's like being the director of a movie, just shouting instructions to a digital crew that instantly obeys.
That is a great way to visualize it. And the crucial mechanism that makes this phase actually work is the instant 3D preview.
Okay, what does that do?
Well, in traditional game engine development, if you make a change to how a fan spins or how a physics interaction works, you often have to compile or rebuild the entire project to see if the change actually functioned the way you wanted. That compilation takes time.
Yeah, I've heard sometimes it takes hours just to test one tiny tweak.
Exactly.
Yeah.
Here, because of that browser-based architecture we discussed earlier, the trainer speaks the command and they see the simulated interaction update immediately.
Immediately.
There are no compilation delays. This allows for an incredibly fast iterative loop. The expert can tweak, test, and adjust in real time until a scenario perfectly aligns with the real-world physics they know from their own experience.
Man, I want to linger on what this actually means for the human beings involved.
Yeah.
Because if we look at the big picture here, for the last 40 years, software development has essentially been a game of translation.
It really has.
You have the subject matter expert, the person who has spent 30 years on an oil rig and knows exactly how it works. And then you have the software developer who knows how to code, but has never even set foot on an oil rig.
And historically, so much time, money, and accuracy is lost in the translation between those two people.
Yes, but with this technology, we are completely removing that translation layer. So what happens to the role of these veteran experts when the AI is doing the heavy lifting and the middleman is just gone?
It is a profound philosophical shift in how we handle enterprise knowledge. The technology does not replace the experts. It fundamentally empowers them to become creators themselves.
That's a huge shift.
There is a very revealing quote in the sources from Dan Lajerskar, the chairman of EON AI Ventures. He states that for the first time, subject matter experts are armed only with their knowledge to create impactful modules.
Armed only with their knowledge. I love that. That completely changes the dynamic. They are no longer consultants on their own training programs.
Exactly. EON Genesis 3.0 acts as a direct bridge between raw human expertise and digital reality. If you have the knowledge in your head, you now have the tools to express it in interactive 3D simply by speaking.
And the real-world impact of that direct bridge is massive.
Yeah.
Instead of just, listing off industries, let's actually look at how this changes the day-to-day reality on the ground.
Sure.
Take the energy sector, for example. What does this look like for them?
The energy and oil and gas sectors are a perfect showcase for this. Previously, if an engineer recognized a new safety hazard regarding, say, pressure thresholds, they would write a memo, update the binder, and just hope everyone read it.
Right, which we know they don't always do.
Exactly. Now, that same engineer can sit at their desk, open a browser, and speak to the simulation. If the pressure hits 500 psi, rupture this specific pipe and trigger the alarm.
Oh, wow.
Now, every single trainee can experience that exact catastrophic failure, understand the warning signs visually and orally, and practice the emergency shutdown, all in a totally safe environment.
That isn't just a cost-saving measure. That is literal life-saving technology.
Yeah.
It turns a theoretical memo into physical experience. What about environments where the procedures are incredibly intricate, like aerospace?
In aerospace and defense, the challenge isn't just safety. It is the sheer volume of multi-step procedures required to maintain complex machinery.
Right, thousands of moving parts.
Creating a training module for a 70-step engine calibration used to be a massive budget line item requiring months of developer time to animate every single step perfectly.
A nightmare, basically.
Now, a senior technician can upload the procedural manual, let the AI build the 70% baseline, and then spend an afternoon verbally tweaking the precise angles and tolerances. A project that took half a year is deployed in a few days.
And it ensures the training is never outdated. If the manufacturer updates a single step in that 70-step procedure, the technician can just open the file, verbally change that one interaction, and push the update to the entire workforce instantly.
It creates a living, breathing training ecosystem. And we see similar transformations detailed in the sources for healthcare and education.
Yeah, I was wondering about clinical settings.
In clinical settings, a medical expert can design interactive equipment training tailored to incredibly specific, perhaps even rare, patient use cases. They don't have to rely on generic medical training software anymore. They can build exactly what their staff needs to see.
I keep thinking about what this means for a university professor.
Oh, it's a game changer for higher ed.
Instead of standing in front of a lecture hall showing a slide deck about a complex chemical reaction, they can just describe the laboratory, the specific beakers, the volatile compounds. And suddenly, their students aren't just looking at a flat screen, they're walking around inside a virtual laboratory, conducting the experiment themselves.
By compressing the development timeline from months to minutes and bringing the cost down from hundreds of thousands of dollars to near zero, it offers an unparalleled return on investment.
It's hard to argue with those numbers.
But more importantly, it finally makes immersive learning accessible to that 98% of companies that were previously shut out by the technological bottleneck.
Okay, let's take a step back and synthesize the journey we have just charted through these sources because it really is a fascinating evolution.
It really is.
We started by looking at a corporate world that was essentially stuck in a massive paradox. You have 98% of industrial companies completely blocked from using XR training.
The XR paradox.
Right. They know it works better. The data proves it yields 4 times faster learning and drastically higher retention. But they simply could not afford the $200,000 price tags. And they could not afford to wait a year for a game studio to build it. They were forced to rely on dry, dangerous text manuals.
The barriers to entry were simply too high, reserving the best educational tools for only the top 2% of the market.
But then we explored how EON AI Ventures is completely flipping that script with Genesis 3.0. By introducing conversational scene authoring, they have taken the entire complex process of coding, 3D modeling, and compiling, and handed it over to an artificial intelligence that operates right inside a standard web browser.
Which is still blowing my mind, honestly.
It's crazy. It uses natural language processing to read your standard operating procedure, translates the verbs into spatial physics, builds the bulk of the world in seconds, and then crucially lets the human expert refine the rest just by talking to it.
Spin the fan faster, add a warning sound. It
Yeah.
removes the translation layer entirely.
It is a completely new reality where anyone armed only with their expertise can speak a 3D training module into existence.
And the ultimate takeaway here is the total democratization of critical knowledge transfer. It ensures that the workforce of the future, whether they are on a factory floor or in an operating room, is trained safer, faster, and with unparalleled precision.
It really does change everything about how we prepare for high-stakes environments. But before we wrap up today, I want to leave you with a final thought, something for you to chew on long after you finish listening to this deep dive.
Oh, I'm curious.
Throughout our entire conversation today, we have focused heavily on standard operating procedures. You know, dry manuals for factories, oil rigs, and medical devices. But if we now possess the technology to instantly transform a written document into a fully immersive, interactive, physics-accurate 3D world just by feeding it into an AI, what happens when we start feeding this technology other things? What happens when you upload a massive historical archive of an ancient city? Or complex theoretical physics papers that deal with extra dimensions? Or even your favorite works of fiction?
That is a truly staggering thought.
Will the next generation of learning involve simply reading a book about a concept? Or will you literally be able to walk around inside the author's mind?
That opens up possibilities far beyond just industrial training.
It really makes you look at that boring, text-heavy binder sitting on the desk a little differently, doesn't it? It isn't just paper anymore. It's the blueprint for an entire world waiting to be spoken into existence. Thank you so much for joining us for this deep dive. Keep questioning, keep learning, and we will see you next time.